Now in this one we're going to talk about beta decay, which is again one of our nuclear decays that we discussed in this class. Now the things that represent a beta particle, you have two ways to represent it. You can either write a B for beta, and that would be the mass is 0, and since this case we're talking about an electron, it's not a proton. They're two different things, so it's kind of almost like an anti-proton, which would be a -1. Or we can write an E for electron. So again, it doesn't have a mass. Electrons don't have a mass that we count in these problems. And then it's going to be a -1 to be an antiproton. Well, let's use carbon-14 again. So again, the mass number is 14. The number of protons is 6 right there. And then we have our electron right here. Well, we now want to figure out what the product of this equation is. Well, the mass number doesn't really change at all because 0, none of that 14 has to go to the electron, so we just write 14. It's the same mass as from the carbon-14. Now, this is a little bit tricky this time. Carbon has 6 protons. Well, what happens here is that in a beta decay, one of the neutrons in the nucleus splits apart. Since the neutron's neutral, that means there's a positive part and a negative part that cancel each other out. Well, that negative part leaves the nucleus, okay? So that's where this electron comes from, is from the nucleus. Well, what's left over is a proton, so we have a proton added to this 6 so that it becomes 7, and now it's a new element, which is nitrogen. Another way to look at it is that you have to make sure it's balanced on both sides. So since there's 6 protons on this side here, that means there has to be 6 on this side. Well, 7 is the only number plus a -1 that equals 6. So that way the -1 and the 7 equals 6, this equals 6, everything's balanced.